Hello students, welcome back. Let us continue with chapter 10 circles. In the previous class or the previous video, we learned about the basic terms about the circle, right? We did a revision of what the different terms are. Based on that, we are going to solve exercise 10.1. This is a very simple exercise. The first section is fill in the blanks and the other section is true or false. This is on page 171 of your textbooks. So while I am reading out the questions, you can guess the answers and we will see whether you are getting it right just the way I am getting it or not. Okay. So the center of a circle lies in the dash of the circle. It is exterior or interior. You have a circle, this is the center. So obviously the center lies in the interior of the circle. So I am just underlining this point over here. The point whose distance from the center of the circle is greater than its radius lies in the dash of the circle. It is the interior or exterior. So now the point from the center of the circle to a point on its circumference, this length is known as the radius. So if I take a length that is greater than the radius, this point is going to lie in the exterior of the circle. The longest chord of a circle is a dash of the circle. We learned that the longest chord of the circle is the one that passes through the center of the circle and this chord is known as the diameter. So I will say diameter. And also what do we know about the diameter? That the length of the diameter is twice the radius. An arc is a dash when it ends endpoints. When its endpoints are ends of a diameter. An arc is a semicircle when its endpoints are the endpoints of a diameter. Then segment of a circle is the region between the arc and dash of the circle. So what is our segment? If this is your arc out here, PQ, and I join this length PQ, then this area out here is one segment and also this area out here is another segment. So what is this area lying between? It's lying between the chord and the arc of the circle. So segment of the circle is the region between the arc and chord of the circle, right? And a circle divides the plane on which it lies into how many parts? We learned that in the beginning of the chapter that it divides it into 3 parts, which is the interior, the circle and the exterior. And the circular region is made up of the first 2 regions, which is the interior and the circle, right? So I hope you are clear with the fill in the blanks. Now let's move on with the true and false. So state whether the following statements are true or false. So line segment joining the center to any point on the circle of the radius of the, so a line segment joining the center to any point on the circle is the radius of the circle. Yes, this is true. A circle has only finite number of equal chords. What do you think? This is true or this is false? This is a false statement because we learned that when I explained you about chords, we had infinite number of chords, right? See, this is the center, we can have infinite number of equal chords, right? Forget this, even if I don't take these chords, I can take the diameter, right? We know that all the diameters are equal for a given circle. So we can have infinite number of diameters of a circle and all these diameters are going to be equal in length. Therefore, this statement is false. A circle has finite number of equal chords. No, it has infinite number of equal chords. So I'll say this is false. Then a circle is divided into 3 equal arcs, then each is a major arc. So let's see a circle. If I draw a circle and I'm dividing it into 3 equal arcs. So let's say these are my 3 equal arcs. So is each of these arc a major arc? No, it isn't a major arc because a major arc, see, if I take this circle, these are 3 equal arcs. Let's mark this P, Q and R, right? But if I take P, Q like this and R over here, then obviously the the greatest arc that we can have in case of 3 arcs is the semicircle, right? So this statement is false. If a circle is divided into 3 equal arcs, each is a major arc. It is false because each of these arcs is smaller than the semicircle. A chord of a circle which is twice as long as its radius is the diameter of the circle. Yes. Why? Because we have learned that the diameter of the circle is the longest chord. It passes to the center of the circle, and also it is twice the length of the radius. So this statement is true. Sector is the region between the chord and its corresponding arc. This statement, what do you think? Is it true or false? Let's check. So let me erase this section. So if I have a circle with center O and an arc, let's say PQ, and if I take the radius from O to P and O to Q, then this is my sector, right? So the sector is what? It's the region between the arc and 2 radii of the circle joining to the endpoints of the arc. So let's reread this. Sector is the region between the chord and its corresponding arc. According to this statement, you have your center. Sector is the region between the chord and its corresponding arc. So chord, and this is your chord and corresponding arc, right? This is the chord and this is the arc so formed. But this region is what? It is the segment. It is not the sector, right? So this statement is false. Because segment is the region between the chord and its corresponding arc. A circle is a plane figure. Yes, this was one of the first thing that we learned while we started with this chapter. So a circle is a plane figure. So I'll say true. So this was about exercise 10.1 of your textbooks. Pretty simple exercise about the basic concepts of a circle. Let's continue with the remaining topics in the next videos. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.